Hello, today we're going to be looking at free response question number 2 from the 2022 BCAP Calculus exam. And before we dive into this question, just a reminder that this is from the calculator part of the exam, so you will need a calculator to complete this problem. So the question tells us that a particle moving along the curve in the xy plane is at position x of t comma y of t at time t is greater than 0. And then it tells us the particle moves in such a way that dx dt equals the square root of 1 plus t squared, and dy dt equals the ln of 2 plus t squared. And then we're told that at time t equals 4, the particle is at the point 1, 5. So we're given dx dt, dy dt, and then our position at time t equals 4. And now part A asks us to find the slope of the line tangent to the path of the particle at time t equals 4. So I've just written out what we know. We're trying to find the slope at t equals 4, and we know dx dt and dy dt. So if we're trying to find the slope, that means we're going to be looking for m. And we know that m equals dy dt, the change in y, over dx dt, the change in x. So we can go ahead and write that out. So therefore, we're looking at the square root of 1 plus t squared over ln of 2 plus t squared. And we know we are evaluating this when t equals 4 because we're looking at time t equals 4. So we can go ahead and plug in 4 everywhere that we have a t. And now we can just plug this into our calculators because this is from the calculator section of the exam. So this concludes part A, and we can move on to part B. Part B asks us to find the speed of the particle at time t equals 4 and to find the acceleration vector of the particle at time t equals 4. So again, we're looking for the speed at time t equals 4 and the acceleration vector at time t equals 4. And I've just gone ahead and written out the equations we need to know, that what speed equals and what the acceleration vector equals. So now we can go ahead and just do these calculations looking at the values we know for dy dt and dx dt. So I've just gone ahead and written out dy dt and dx dt, and I've plugged in those values for speed. And now we can just put this into our calculator, and we get 5.035 is the speed. So now we can move on to acceleration. And again, we're going to be looking at the same dy dt and dx dt. So we just need to find the double prime of x and the double prime of y in respect to t here. And that will simply be our acceleration vector, and we'll plug in 4 for t. So that concludes part B, which is finding the speed and acceleration at time t equals 4. So now we can move on to part C, which asks us to find the y-coordinate of the particle's position at time t equals 6. So since we're looking at the y-coordinate at time t equals 6, there are a couple of crucial pieces of information that were given in the instructions or the question. So we know what, we've used this a couple times, dy dt is. So that's going to be our change in the y value. And now we also know the y-coordinate of the particle at time t equals 4. Because at time t equals 4, we're told that the particle is at the position 1, 5. So we know that the y-coordinate here is 5. So we're going to be looking for the y-coordinate at time t equals 6, which means that we can take the y-coordinate at time t equals 4 and add the amount of change from 4 to 6. So that will be looking at the integral of dy dt from 4 to 6. So I'll go ahead and write that out. And I'm so sorry, I wrote the wrong thing. I wrote dx dt down, so I'm just changing that to dy dt here in the answer. So again, just to clarify what we've done here, we've taken the condition of our starting point, and we're starting by looking at time t equals 4. We've taken that condition here, 5, and that's what we're starting with. And then we're adding the change in our y value, which we can look at as dy dt. We are adding that change. So the amount of change is the integral from 4 here 2, 6, which is what we're trying to find, of our dy dt. And so now this is something we can just plug into our calculators to get the y-coordinate at time t equals 6. So our y-coordinate is 11.570. Now we can move on to part D. So part D asks us to find the total distance the particle travels along the curve from time 4 to 6. So again, we're looking at the total distance from time t equals 4 to t equals 6. And we can do this by looking at the integral of our calculation for speed. So we found that, or we know that speed equals the square root of dy dt squared plus dx dt squared. So in order to find the distance that's traveled, we can look at the integral of that square root blah, 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 blah. So let me just write that out. Now, it's important to point out that this asks us to find the total distance. So in case this particle was moving backwards and then forwards, right, then left, we would want to look at the absolute value while we're taking the integral, just to make sure we're getting the total distance, not just the distance forward. So let me just write in the absolute value here. So now we can go and apply this to our specific situation. So we're going to be looking at the integral from 4 to 6, and obviously we have our dx dt and our dy dt. So you can go ahead and then plug that into our calculators. I'm just going to write it out because I think it's helpful to see it all put together. Okay, so I just think this is helpful to look at written out, plugged everything in, and now I'm just going to type this into the calculator to get our final answer. And we get 12.136. So this concludes looking at parts A, B, C, and D of question number 2. I hope this was helpful.